Thank you everyone for coming to our webinar today, Advancements in Laser Scoring Recyclable Packaging Films. Your presenter today will be Jim Borgen. The timing, so Jim will give a 15-minute presentation, and then we'll have question and answers at the end. You can submit those at the bottom via the Q&A button at any time in the presentation if you want to. This session is being recorded, and a recording of the presentation will be sent out to all of the registrants once we finish, so late this week, early next week. Our agenda is why this matters, sustainability considerations, overview of laser scoring, controlled depth scoring, Preco software and tools, AccuPower laser power control, and best practices. Jim is the key account manager here at Preco, where he spent 35 years, more than 35 years, helping manufacturers implement advanced material processing solutions. He studied electronics technology at Rochester Community College before serving in the Air Force. At Preco, Jim advanced his roles in service engineering, sales, and project management, giving him a deep technical and practical understanding of the company's systems. And today he leverages that expertise to partner with key clients and deliver customized converting and automation solutions to improve efficiency and drive results. Jim, I will turn it over to you.
Thank you, Quinn, and hello, everybody. And I also want to let you know this is my first time hosting a webinar, so please bear with me. Why this matters. Today, consumers and governments are pushing for eco-friendly packaging. Brands are under pressure to meet recyclability without compromising functionality. Laser scoring enables easy opening of packaging layers without adhesives or non-cyclable components, improving recyclability. So as you can see here, this package is just shows something that I'm sure a lot of you or all of you have experienced as far as opening a package. A lot of times it has a little tear notch, and then you just grab the top and pull, and it tears nice and smooth. Most of those packages would have been laser processed probably by Preco equipment. And so regulations like extended producer responsibility, EPR, and EU packaging and packaging waste regulations are pushing companies to design packaging that is easier to recycle. Sustainability considerations. Laser scoring is a fascinating and precise method used to create controlled weaknesses in packaging materials, making them easier to open or separate while maintaining barrier integrity. Laser scoring is a non-contact process, reducing tool wear and waste compared to mechanical methods. So that means that the material will absorb the laser beam to start the separation of the web material. And as you can see, this picture shows the laser beam engaging the surface of the film as it passes underneath the laser heads. When it comes to recyclable, flexible packaging, the challenge is balancing functionality with sustainability. Here's a breakdown of the key methods of laser scoring for common packaging materials. So the laser removes material from the top layer without penetrating the entire structure. So as this shows, that laser beam is just engaging in or going into the barrier layer most of the way. And so it's ideal for monomaterials films where only a slight weakening is needed. The benefits are to maintain barrier properties suitable for recyclable films like polyethylene or polypropylene. Laser scoring helps overcome this by creating a controlled tear path without compromising recyclability. Technologies like closed-loop laser power control deliver precise score depths that weaken only the outer layer of the film, preserving barrier properties and ensuring consistent tear performance. Traditional mechanical methods can also score material but could introduce contaminants, making recycling more difficult. So Preco software and tools. The Preco software, AccuFlex, is used to set up the lasers for controlling score lines for functional accuracy. As far as the tools go, Preco patented beam compression unit, which we call BCU, is a device used to focus the laser beam to weaken the material along a predefined path. This creates a tear line or easy open feature without compromising the overall structure. So this little spark right here is where the laser beam is exiting the BCU and ablating the surface of the material. And then Preco has also designed a high-speed detector, which is closed-loop laser power control, which precisely controls the laser power to control the score depth down to single microns. So this graph shows the difference in closed loop compared to open loop. The closed loop is the pink dotted line. And as you can see, the closed loop maintains much higher control, which is important for consistent score depth. Monomaterials like polyethylene and polypropylene are highly recyclable, but hard to tear. So laser scoring helps overcome this by creating a controlled tear path without compromising recyclability. In one case study we had, because of the lack of absorption of the laser beam to the polyethylene, when we looked at a cross-section of the film, the material had more of just a damaged look to it than a nice valley, but it would still tear it nicely. So you can see that we penetrated the material only by 20 microns, and so that's all it takes in a lot of cases just to be able to tear the material on a consistent basis. So that's it for the webinar. Any questions, Lynn?
Thanks, Jim. We just have a couple questions. So the first one is, how do you prove that your laser process will work on my material?
Okay, good question. As far as any time that we have a new process, regardless of what it is, especially in packaging, I will come up with a test study that we will perform. So we'll choose the right system to process your material and then prove it out in that fashion. So we'd take it a cross section after we score it. In this case, that's what we're talking about, is scoring. So we take a cross section and look at it to make sure that we're penetrating the material as well as we can, and then also do tensile tests to confirm. That's about what I got for that question.
Awesome. Is scoring with a laser a slower process than other methods?
Okay. As far as being slower, no, it's not. I always joke about this. We're moving at the speed of light. So basically, I've seen systems that have run in excess of 2,000 feet a minute, which is incredible. So no, it does not run slower. And then again, with the laser light does not dull. So as far as comparing it to mechanical, it will last a lot longer.
How do you test the score to confirm it is acceptable?
Okay, well, similar to the first question, but what we'll do is we'll put it in the tensile tester to actually test to see how much it takes to separate the material based on a 1-inch wide strip to give us a tensile readout. And then the other thing is just a simple thing is, as far as just doing the tear to get a nice tear propagation is the other thing that we look at to confirm that we're getting what we need to get.
All right. This one is recycled films are not consistent. What hurts do you recommend to process best?
Well, I'll tell you what, that one is a really good question because a lot of times that's going to vary because what we will do is we will decrease the hertz or the frequency uh, based on the material, based on uh, what we're looking for tear propagation. So I mean, we're in the 20 kilohertz a lot of times. I think is where we're at. I would have to confirm that. So that's something that I'd like to be able to get back to this individual on.
Sure.
But yeah, that's in a nutshell. It does vary, and we have that control in our system, of course, in our AccuFlex software, where we can change the frequency based on what's required. And again, that's the reason for the test studies, because we are changing the frequency on a lot of occasions. So I hope that answers your question.
So the next one is your thoughts on with testing versus tinsel. What is better?
Another good question, because in my opinion, as far as getting a nice tear propagation, that's something that is the first thing that we're going to test when we're doing a test study, and also when we do our inspection plan. That's something that we're doing all the time as we test the material at the end of each roll. So the tear propagation. Then we also have, of course, we need to test the tensile because we don't want the package to burst if it's dropped or something like that. So we want to have a high tensile, but a nice tear propagation. So it's a combination of those two things. And then the other thing that we will look at is, like I say, we'll look at the score itself with a cross section and just confirm that it's a nice score.
I would assume so. His next question is, or this next question is, do you recommend depth testing? So I would assume that is.
Yeah. Yeah. So that would go right along with what I just said about, using the cross section on the microscope. So we would look at that because that's the other thing too, that we do not want to damage the sealant layer. And the other thing that we do is, as far as ensuring that we're not damaging the sealant layer, is a lot of times too, we'll put the scored material into our airflow system and to make sure that we do not have any leaks. That's another thing that's very important. So yeah, good question.
That was the last question. So Jim's contact, I'll give another minute in case anybody has something that they just thought of. Jim's contact information is on your screen. If you have any questions, feel free to reach out to him. That is all we have for today. So I want to thank Jim again for his great presentation, and thank you all for attending.
Thank you.
Thanks, Jim.